Hey, everybody, and welcome back to another episode of JavaScript Jabber. This week on our panel, we have Steve Edwards.
Howdy from Gray, Portland.
I've got a host here that says AJ isn't here. Yeah, he just unmuted and then remuted, so he must not be here. I'm Charles Max Wood from Top End Devs, and this week we're talking to Dejan. Do you want to introduce yourself? Just let people know who you are and why you're famous.
Yeah, thank you. I'm not famous. I'm trying not to be. I'm a developer. I'm now in the third decade of my professional experience. And at the moment, for past 8 or 9 months, I'm working as a developer advocate for RavenDB.
Oh, cool. Hey, folks, this is Charles Max Wood from Top End Devs. And lately, I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com. So yeah, that explains you wanting to come on and talk about NoSQL databases and stuff like that. Do you want to just explain what RavenDB is, and then we can kind of backfill into NoSQL and what it is and why people care and all that good stuff?
Sure. RavenDB is NoSQL database. So in general terms, NoSQL is not negation. It's short for not only SQL. And this category of the database is emerged in the 90s, where companies like Google, Yahoo started solving really hard problems. So they had to develop new ways to handle large data. And RavenDB emerged around 2009. We can talk a bit later on how it was born from frustration. So 13 years later, second generation multi-model NoSQL database.
Gotcha. Yeah, it's interesting, right? Because I remember that it kind of hit its heyday for a while. People were using like MongoDB and CouchDB were kind of the ones that I kept hearing about. And then you've got Cassandra and Voldemort and a bunch of other ones, right? That all do different things, and they seem to be kind of optimized for specific problems. And then, I don't know, SQL kind of got its renaissance, right? Where people realized, most of the stuff I was trying to do with Mongo, I can do with SQL, but there still seem to be quite a few people out there who are looking at some of these NoSQL options and having it add up to something that makes sense for them for whatever reason to use a NoSQL option. So I'm curious as we kind of dive in, what kinds of problems, if I'm facing this, that, or the other, am I going to be looking at something like a RavenDB or a MongoDB or, one of these other options out there and going, I'm going to use this instead of my typical SQL database to solve my problem? And what is it about those that makes them a good fit for those problems?
So I can approach this from my personal side. I was a developer using SQL Server and MySQL for a long period of time. And eventually, I ended up as a C# developer using Entity Framework. So Entity Framework is ORM. And I noticed following pattern on every single project I was doing. I complete it, and it turns out 80% of the code is working fine. And the remaining 20% is making problems for me. And my first instinct, of course, is I'm not doing something right. So I'm not expert in this. I need to learn more. I need to go and talk to people who are really experts. And then I started meeting other people, other developers who had the same problems. So usually as C# developer, which I am, you end up taking those 20% of your code, introducing something like Dapper, writing SQL queries and commands by hand and replacing that. And this works, but it actually brings whole house down because you don't have this nice modeling, automatic generation of SQL anymore. Migrations are hard. It's
Right.
a bit of a problem. And I also noticed I'm reaching for the Redis more and more by default. So I'm starting a new project and I'm immediately thinking, will this be slow? Will I need Redis? Let me put Redis right away. And it's a bit like, maybe it's too harsh to say you get a bit insecure about yourself as a developer, but I was feeling a bit like that. So I was feeling you need to be really, really devoted to the database to be able to produce really high quality solutions.
Right. I've kind of heard the argument from some people that if you run into speed issues with a SQL database like PostgreSQL, a lot of times you haven't set up your indexes right, things like that. So how do you know if it's that kind of performance tuning that I can just do on a SQL database versus, hey, I really ought to just have a look at one of these other systems that seem to solve this problem?
So the thing is, you want to have something that's called bit of success. And the bit of success is like a setup of technologies you're using which are guiding you towards success.
Mm-hmm.
It is true that you can go and introduce indexes and fine-tune and observe, and you spend a lot of time on it. So part of the story behind RavenDB is precisely that. Guy who created RavenDB, Oranini, most people know him by his blogging name Allende. He was developing in Hibernate. He was participating as a developer on an open source and Hibernate project. After that, he started working as a consultant for companies using relational databases. And after a certain period of time, he figured out that developers and companies are repeating same mistakes over and over again.
Mm-hmm.
So his first instinct was, okay, as I'm usually joking, to be a good developer, you need to be a bit lazy. So what you try to do, you try to optimize. So first instinct was to create the application or let's say profiler, which would be detecting these anti-patterns that developers are creating, like select n+1 or queries without index, things like that. And then he got really frustrated about the state of the things. And he was inspired by the Couchbase, and he started thinking what could be ideal database, or what could be a database that is preventing all these problems. So instead of solving problems this way or the other, let's try to produce system which is preventing you from creating problems. So I can give you one example. A conscious design decision with RavenDB was to disallow, to make it impossible to run query against raw data. So all your queries are always going through indexes. So what happens if you don't create index? Well, RavenDB steps in and create one for you.
Okay.
So is that a permanent index or one just sort of a transient index that's there for the duration of the query? I mean, if I query against something, a table that doesn't have an index, and you said Raven creates one for you, does that store that permanently in the database and so it's there the next time, or is that just sort of a transient index for the life of that query?
So general strategy is to produce grown-up database, as we like to say. So database without the need for a nanny. So we like to think there is no such position as a full-time DB administrator for RavenDB. So speaking about the automatic indexes, whole story is that RavenDB again tries to optimize things. So you have some settings which you can change, but with default settings, automatic index, if not used for some time, will become idle. And after period of idleness, it will be completely wiped out. So if you don't, so your query will trigger index creation. If your application continues to use it, it will be active and catching up new documents, things like that. But if this was one time only for some ad hoc data investigation, after some time it will become idle, and after some time in idle state, it will be removed.
So is that a setting then where you can set your time parameters, keep this for a day or a week?
I think it's 72 hours is default setting. So if you run it after 72 hours, if there's no queries again which are using this index, it will be completely wiped out.
So my weekly report then would reconstruct the index.
Yes.
Every time I run it.
Now,
unless I tell it specifically, hold on to this longer.
So then how does that work if let's say it creates it on the fly and you decide, okay, I want to keep it. And I assume you can go in and save that index to become permanent. or maybe just stretch out the time, the default time value?
You would change default time. You cannot. So you have two classes. One are automatic indexes. They are managed by the database. And then we have so-called static ones, which you program in programming language of your choice. Let's say in C# or Java, you inherit abstract class, you program it, and this is static index, which is not touched by the database. So it won't be deleted, it won't be idled. You took control over index. But if you don't take control over index, if you let database create it, then database will manage it.
So if it's in the code, then does that mean that, let's say it's in your code and you don't use that query for a while because for whatever reason, that particular procedure isn't used in your application very often. So then the code is going to generate that index for you in Raven. That's what you mean by it's controlled by the code?
Yes. So you code it as a class, you deploy it, and there it is. It's completely managed by you. So it's your choice if you're going to delete it or keep it or expand it with additional fields, things like that.
So I'm going to guess that the Raven must be somewhat efficient in terms of building the indices if you're building them on the fly and deleting them on the fly like that.
It's quite capable. What I like, especially when you download it, if you want to install it on your machine, it's like 82 megabytes archive, which you unzip. And this database, which is zipped into 82 megabytes, can run a database which is like 15 terabytes size. You can run huge clusters, things like it's you could say it's really scalable. So this is something you can use for your own hobby project, or you can set up cluster consisting of like 30,000 nodes communicating together.
Interesting. So that kind of opens up the scaling argument, as far as like, I've seen all kinds of different schemes for scaling, different kinds of databases. Some of the databases have, I guess, better mechanisms built in for this than others. But that's interesting for sure. One thing that I'm kind of curious about, though, is that you kind of mentioned that this database is sort of a self-optimizing database, right? So it watches what queries you're making, and then it'll create the indices and things like that, like we're talking about. Mm-hmm. What other optimizations does it make? Like if I'm making other queries into the database beyond indexing, are there other things that it does for me automatically?
Yes. So I already mentioned automatic indexes. As you're running your queries, some of these indexes will be merged together. Then if a database detects that indexes are overlapping, some of them which are obsolete will be automatically removed, and your queries will still be served. And then there's a lot of like internal reconfiguration happening as you use. So for example, if you're running RavenDB on a machine where memory is larger than the data set, it will bring up whole data set into the memory, and it will serve your queries from the memory completely. It will be still persisting your writes to the disk, but the reads will be served directly from the memory. And this is happening automatically without a need to touch anything. Then it's also about observing which queries are more frequent and allocating more CPU and more memory to these frequently repeating queries. Then it's also about the cluster. So if you have cluster of, let's say, 3 nodes, you have option to say, I would like to work with the fastest node. So once per minute, a RavenDB client as a part of your application will measure latency and will pick up the fastest node to work with. If this node goes off, you will have hot failover to next node in predefined sequence. So lots of things are happening behind the scene based on the actions that you undertake towards your database.
That makes sense.
Hey, Chuck, can we step back a minute? I want to do some clarification. It seems like in our initial introduction, and I know at least in my brain, I've always sort of grouped NoSQL databases as the same thing, Mongo's with Raven. I was talking with AJ ahead of time, and he was saying that Mongo is not a document database the way Raven is in terms of how it deals with caching. Is that true or false? So how would you differentiate between Raven and Mongo in terms of their structure and how they work?
Probably the biggest difference is inside of the RavenDB, you have actually 2 databases. One is key value store, so you read and write, and the other one is Lucene.net. So all these indexes are built inside of Lucene and served from Lucene, which means that out of the box, you are getting full text search, spatial indexing, suggestions, highlights, everything that Lucene offers.
Yeah. Okay.
This is
So
probably the biggest.
That's cool. That's interesting.
Yeah.
And I say that as someone who's spent many years working with Apache Solr, which is based on Lucene, and currently with the stack at my current day job, we use Elasticsearch with MongoDB, which is built, and Elastic is also built on top of Lucene. So yeah, Lucene is definitely the way to go from a search standpoint in terms of giving you key value storage, speed, and indexing, and that kind of stuff.
Yeah, it's interesting too, because when I think of document database, I'm thinking more along the lines of MongoDB, right? Where you have like a pseudo structure, I guess, right? Where it's schemaless, but you have the keys for each value or column, I guess, for lack of a better way of putting it. They don't really do columns in the same way SQL databases do, but for each value on your object. And what you're saying is that you just stick it in a key value store and then you build search indexes off of it with Lucene, which
so you
would make it super fast.
You take whole JSON and you store it inside of internal storage engine, which is like optimized. So, for example, there's internal format, which is called bulletable, where you can access properties of your document in non-streaming manner. So you can just pinpoint, and so indexing process can pinpoint and take just specific value and index it.
Right.
So if you're fetching by the key, you get whole JSON from the key value store, which is super fast. If you're querying, then your queries are always going through indexes, and this is fast again because you are picking up from the disk. Engine will pick up pre-computed results. So what is interesting that you want to be resilient against large data volumes. So let's imagine you have e-commerce store and you are calculating some aggregates for the daily sales or the monthly sales, something like that. So aggregation will be done once. Results will be stored on the disk. And then it doesn't matter if you have 100 shoes sold or 100 million shoes sold, because aggregates will be computed once, stored on the disk, and then queries are just filtering pre-computed results.
So does Raven do the aggregation by default somehow, or I would assume you would have to tell it how to aggregate it because you're going to want it a certain way, right? That's one of the benefits of Elastic. Is I know that we use this, it handles aggregation, something we use quite extensively.
Yeah, for simpler aggregations and simpler operations, you can run queries and automatic index will be produced. But if you want to take more control or to use advanced aggregations, then you write MapReduce index on your own. Map phase, which is producing indexing entries, and then reduction phase, which is like performed recursively in several steps. So originally, MapReduce was developed by Google in around 95, I think, and it was developed as a technique to take petabyte scale of data and run it across data farm in parallel. So it's like massively parallelization of data processing. And same technique is applied here only on the microscale. So you are doing this parallelization on the CPU threads.
So kind of talking through how this all works, I guess the question comes back to, when am I going to want to pick something like this over, just stuffing my data up into PostgreSQL or something like that?
Well, I would now jump to one of my favorite topics, which is domain-driven design. I think this is great technique. So if you're going, for example, with domain-driven design, or if you're really trying to model your business domain or whatever domain may be in a good way, then with document database in general, so whatever document database you pick, you can develop your business domain model, store it directly into the database, which is important because you eliminate ORM, you eliminate this translation between object graph in the memory and the tables in the database. You're not translating back and forth anymore. You don't have this impedance mismatch anymore, and whole persistence layer is gone. So less programming. You just work with one set of data structure, and you just throw them at the database, and database knows how to store collections without you going and splitting it artificially into like tables, because a relation database cannot hold collections. So I think this is the biggest advantage. So when you're speaking about NoSQL databases, it's not about the speed or indexing. It's also about developer experience. And if you think about it, you develop project for a year, and then for 10 or 15 years you exploit it. So if you think on the grand scale, like development phase is like 10%, and the maintenance and the life cycle is like 90% of the time.
Mm-hmm.
So if you make changing things easy, you won't hesitate to modify your code, data model, etc. Which means that this agility, holy grail everyone is pursuing, is actually about the how easy it is to make change.
Mm-hmm.
In my career, I had cases when customer comes to me and asks something very simple, and I go mad because I know it will take me 3 days. And then I start thinking, is it normal for like 2 sentences requirement change to result in 3 days of work? It's not. This is indication that I was doing something in suboptimal way. So when I switched to NoSQL databases, I noticed things like these are gone. Of course, I'm not saying that you cannot do wild things in NoSQL databases. There's nice story about early customer of RavenDB who took notion of document database quite literally, and he was complaining about performance. When support looked into the case, it was actually that whole database was a single document.
Oh,
so it was like document database literally. Those were the early days of document databases. So you're not prevented from making problems or challenges, as people would say, as people would put it, but you are somewhat more directed towards elegant, simple solutions. Because if you think about it, or if you start reading literature, you run into the notions of like essential complexity and accidental. Essential complexity is the complexity of the domain itself, and accidental complexity is what all this mess that we developers introduce around the actual domain that we are in. So if you have many moving pieces, if you put Redis in front, you need to know when to invalidate it. If you use several layers of abstraction, you need to update them all. You need to do translations between like boundaries of the subdomains, things like that. If you switch to microservices, right away you introduce huge amount of accidental complexity. You need to change the way you're testing things. Otherwise, you end up with distributed monolith, which is even worse than monolithic monolith. So you need to cover the cases where if one component of the system or one microservice of the system fails, not to have cascading failures, etc. And also, when you look at it again, you had polyglot programming movement in the 90s, and on the wings of that, we ended up with projects where you have microservices which are implemented in different languages. Because if you're doing like machine learning, it's highly probable that you will go with Python. And you can mix various languages in one project with microservices. And microservices are actually maybe even more about team organization than actual technical choices.
Mm-hmm.
And then based on that, you should also go and pick up the best persistence mechanism for each of these microservices. So if you have a need for full text search, you should go and pick up the right tool for that. And there's nothing wrong with going with multiple strategies for data persistence.
I don't know. I mean, everybody talks about microservices like they are the absolute bomb. They'll solve all your problems. And I think in some cases, especially you're talking about domain-driven design and the way that some of this stuff comes together, yeah, I can kind of see my way around to having a few services, again, depending on how the domain actually appears, right? How things interact across the knowledge domain, as opposed to splitting it up, like you said, according to the organization that is building it. But yeah, you add a whole bunch of complexity because you have that communication medium in the middle of it that you have to figure out, and you have to make sure that everybody knows how to talk to everything else. Whereas typically, if you're within the same framework or program, then the system kind of handles a lot of that for you. And I'm not saying that one is necessarily a poor choice, but it needs to be a deliberate choice based on the actual interactions that occur within your application and how you want that to work. But yeah, then you can start making choices. But I've also seen apps where they have like they use both Mongo and Redis and PostgreSQL and something else, right? And they just have the different drivers in there, and then they're different systems, it's like this piece talks to the Redis database and this piece talks to the Mongo database, but they have distinct reasons why they've picked those. And so I think that's kind of what you're talking about. It's just knowing, hey, look, this data, this behavior is best suited to the structure.
I usually go with the rule of thumb that I need to be able to explain to myself if I'm using certain approach or certain piece of technology, which problem it is solving.
Mm-hmm.
And I'm calling this driving on autopilot. I don't want to be driving on autopilot. I don't want to have cookie cutter and produce every project in the same manner. So if I cannot defend this decision in front of myself, then I'm thinking, okay, I'm not going to use it. And this comes to the databases as well. If I'm not able to provide clear explanations. So when I was leading teams, it was never, okay, I'm the boss and I'm tech lead. You need to accept my decision. If I'm not able to defend or explain my decision so that everyone agrees or confirm that I'm thinking right way, then we're not going to use that.
Yeah, I'm kind of in the same boat where typically I'm picking a PostgreSQL backend database, and I kind of have a set of defaults that I'm using. And then, if I deviate from that, it's because I can actually justify it with a real reason to do so. Otherwise, it seems a lot simpler just kind of keep everything in the same place.
And it's also sociological aspect to it. If you have a team and the team members are proficient in Postgre,
mm-hmm.
that's probably what you're going to go with.
Yep.
So it's technical decisions are not just technical decisions. They are multifaceted decisions, and you have to live with consequences. And I know a couple of developers who are praising microservices only for me to find that they went through 3 companies in 5 years. They developed microservices project, and once it's launched, they move to another company, and
mm-hmm.
they don't have to live with consequences of their choices.
Right.
And 2 a.m. calls and things like that.
Can y'all hear me now?
Yes.
Yep.
Okay, finally you can hear me. Yes, I've tried to butt in a few times now. And anyway, on the subject of microservices, I would like to point our listeners to Ethan Garofalo, who gives, I think, really good explanations about how to architect. Because, like was said earlier, if you just have a distributed monolith, then you're worse off than having a monolith. And a monolith is not necessarily bad, and microservices are certainly not necessarily good. When it gets to the point where a single developer can't run the system on their machine or on a VPS because there's dozens and dozens of keys and services, at that point you better be pretty big enterprise, because if your startup needs 12 different services in order for your social media app to work, then you're really over engineering it, but not actually over engineering it because it's not engineered well.
Yep. So I did want to kind of switch gears here a little bit, or maybe go multimodal on this podcast episode. There's a pun. But you mentioned that Raven is multimodal.
Sorry, I was a little late on that. It wasn't ready.
Better late than never, right? And I've seen this, right, where people reach for the key value stored database for certain things, and then they reach for the document database for certain things, or they reach for, I've heard Cassandra explained in a couple of different ways, none of which really had any meaningful application for me. But how do you approach the different types of NoSQL databases, and how do you feel like each of those should be used? If I'm starting to make these deliberate choices, hey, I'm using the kind of the default whatever I normally use, and it's just not doing what I need it to. How do I go about looking at some of these other options to say maybe this is going to set me up for success?
So I think again, every decision should be completely conscious, and
mm-hmm.
you should think, okay, what problem I do have here, and what's most appropriate solution. When I say most appropriate, not necessarily the best, because you should also look at the price and the learning time and the maturity of the technology.
Right.
But with multimodal databases, they are sometimes called second generation NoSQL databases, because they started with the single. So you have 4 major categories of NoSQL database: key value stores, document databases, graph ones, and the Y column store. So the
mm-hmm.
Cassandra is, for example, Y column store. And most of them started from one category, and then they started expanding to other ones. So, for example, all of them are essentially key value store because that's most basic functionality. But if you just need key value store, probably Redis is a solution for you. You're probably building some kind of caching mechanism or coordination between a web farm, machine, things like that. Now, RavenDB over years, and this is something I like, new things were not invented by the ivory tower architect. They were precise requests by people who were using, who were running into problems. And then answers to that were introduction of, for example, ability to store time series data, ability to store binary data as attachments. So in Raven, you're not mixing JSON documents and zip files or photos. You have concept of attachments. So you, in the same manner as you would do with email, you attach binary files with JSON documents. And these binary files will be isolated from JSON documents, but related. In other words, if you upload 15 gigabytes of video files, this will not choke your access to the JSON document. So again, it comes to the choice of most appropriate tool. So if you have 7 or 8 ways to model things, then you have better opportunity to choose the right solution to your problems. So if you have Internet of Things project, if you need to accept and store and later on analyze trends for hundreds of thousands values per day or per minute, you can store that into a relational database. But better solution is to find database which is offering time series storage. So again, yes, you can use assembly and write website, e-commerce website. There's no technical obstacles, but what you need is to actually have a life where you will devote yourself to actually building application, not wrestling with the technology. So if you need to store stream of devices sending GPS coordinates, if you're building like a shipping company tracking of the trucks, you can use relational database, and you can use also MongoDB in document mode, but it's way better to use most appropriate tool for that, which would be time series supported database. And then it's also the case of if you, for example, using CQRS as approach, you want to separate models for writing data and reading. So when you're storing documents from your domain model. When you're reading, you essentially need some kind of equivalent of view models. So you want to combine data from different collections or tables into one single view model. And then if your database can support that, it will be more pleasant for you. So instead of joining 8 or 9 tables, you go and use, like, for example, RavenDB has projections where you can use JavaScript on the server side to create projection, to execute code, and you get your view model directly from the database. You just need to throw it to the view and render it.
Gotcha.
So I got a question in terms of clients. So looking at the Raven documentation, the different client libraries that are APIs that I see are C#, Java, Python, and Node.js.
There's also Go and PHP under development.
That's where I was going. As someone who works with Laravel quite a bit, I was going to ask you about PHP options as well.
P is coming, but interesting detail here is, again, design decision, conscious one, was to reuse existing technologies and protocols whenever possible. So a communication protocol for RavenDB is HTTP. There's no proprietary protocol. We are leveraging HTTP. And then as a result of that, sometimes RavenDB server will respond to your queries with 304 not modified. I hope it's 304. I'm keeping mixing 302 and 304. Well, so database will respond 304 not modified, empty payload on the body. You're already holding the latest result set. Go ahead and use it because RavenDB is leveraging e-tag. So every result that database delivers to you is marked with e-tag. So RavenDB client, will send query again, and e-tag basically saying to the server, here is my query, and here is e-tag, which is marking result set, which I'm already holding. And then if there were no changes in the meantime, if response is the same, server will just respond, not modified. Go ahead and use what you already. And these are small details, but they are like free lunch coming from the decision to use HTTP as a protocol. Or very important thing, if you look at the data breaches lately, they're not hacking anymore. It's walking through the open door because you have Elasticsearch, for example, set up, and it's unprotected. So these data breaches are walking through the open doors. So again, the reasoning was like this. We are using HTTPS as a protocol, and we will protect it for sure, always. So we are going to use HTTPS. And then, since we are using X509 to protect our HTTP traffic, let's use this same certificate as authentication means. So there is no credentials. Instead, you are using X509 certificate to identify yourself. That way, you are eliminating credentials completely. You are eliminating like default credentials, which needs to be changed. Whoever installed any relation database remembers you have a like administrator account, and you need to either set or change password after installation is done. So what happens if you forget to do it? If you have with SQL Server, if you have SA or something like that, SA empty or SA password. So you see, security.
So for the web developers in the room, SA is the Windows version of root.
System admin, right?
And also, when you think about it, security is more or less done thing. We know what works. When you log into your e-banking, it's completely protected. Everything is functioning nice. So then when you look at the design of system that would be secure, it's about decisions what to use. So if you need to spend 2 hours securing your cluster after you installed it, if you need to read 40 pages of the manual, or if you need to bring over experts on security to protect your cluster, you have non-technical weak points. So precisely for that reason, the conscious security design decision was made to make everything secure by default. So by default, all requests not coming over HTTPS are rejected. All requests without certificate are rejected. There's no default ports which are open. You would have to close. So this is also part of overall security. And you're speechless.
So, folks, I'm here with JD from Raygun. JD, you guys get like 1 billion errors a month. What are some of the more interesting errors that you've seen over the years?
Oh, that's a good question. We certainly deal with a lot of errors. A couple of things come to mind. When we very first launched, and we kind of expected, we'd see some people sign up and try it. We actually got one of the top 10 Facebook games. Remember when they were huge?
Mm-hmm.
Yeah, and so one of the top 10 Facebook games, and it was, between us, one of the most buggy bits of software I've ever seen. And so it managed to completely blow us off the internet in like our first week of launching. So we solved that.
That's why I couldn't win at poker.
Those Farmville animals, no.
Yeah.
And there was another one always sticks in my mind, because obviously we track JavaScript, and just like with mobile error crash reporting, you can't access the end user's browser console to see errors. So you really want to track that and report it.
Right. And
I remember this one customer, and they had this really fancy animation on the cursor on their website. Mm-hmm. And unfortunately, their JavaScript to do that, they deployed a bug with it, which meant that on every single mouse move event of every single customer they had would send an error report to Raygun. So, working at Raygun is like dealing with a constant distributed denial of service attack and doing it with style.
So if you want to know what kinds of interesting things are going on that you're not seeing in your app, you have to check out Raygun. They're doing a free trial right now. You can get it at raygun.com.
I actually want to go back a little bit, if it's an all right time to jump. I like what you're saying about Raven in terms of automatically creating indexes and automatically doing this, that, and the other. And I did miss a really important part where you were talking about some specific differences between Raven and Mongo and potentially something else. You started to say that, and I had an internet problem. So I missed some of that context. But what I have wanted has been essentially what I see as the problem with GraphQL is that what we needed is somebody to standardize how to do the nested queries with REST and how to give a good standard with REST for this is how to get basically your initial object, and this is how to cherry pick keys. We just need a syntax for that. We didn't need an entirely new technology. We just needed somebody to kind of provide, okay, use dots, use square brackets, that kind of thing. We didn't need a whole new complex server. And with Postgres, it seems that, yeah, and I think in some cases these tools do exist. They're just not very popular, but I really don't want a new database. I just want something on top of Postgres that's a little client layer that when I, like you said, I make a select on something that wasn't indexed, that it just does a quick alter table and puts that index in there. And I want the ergonomics of Postgres to be better, but I have a hard time believing that there's some sort of technology that over the past 30 years of databases that we somehow discovered that's new. It just seems to be ergonomics. So with Raven, why not just provide ergonomics over an existing database? Why create a whole new database system? What's the pull on that? Or is it just that it's too hard to market that ergonomics layer?
AJ, I think you should call it PostgreSQL. Sorry.
All right, Steve, where's your
No, it's all good.
Steve's
Go ahead.
out to lunch.
Sorry. Play here again.
So what you just stated actually happened.
There we go. Better late than never. Sorry, Dan.
Perfectly. So what you just stated actually happened. If you're aware of the Martain is a layer on top of Postgres, and actually author of Martain was using RavenDB and then decided to go and build same ergonomics layer on top of Postgres. There are a couple of things that I think are important.
How do you spell that?
Marten. So this would be like document database like layer on top of Postgres. So storing JSON within the Postgres and then providing various capabilities on top of it.
Okay.
So also you're using document database in a different way than I'm familiar with it. Because I'm thinking of document database like CouchDB, as in literally it's documents and you're building out your caching layer, you're doing your queries ahead of time, and you're providing documents, whereas you're using document database just to mean something that's optimized for JSON, I think.
Not necessarily for JSON, but it's more like you start modeling in Java or C# or Python your domain model. You do that in the best tradition of domain-driven design, being completely persistent, unaware, or not putting DB at the center of your process, of your modeling process. This is what I'm seeing across companies. We start new project, we draw on the whiteboard, they draw boxes, and I'm living in a dream that they are doing modeling. And then when I see FK, I know we're doing. FK is a foreign key. They were modeling database all the time. So first important thing here is that you are detaching yourself mentally from the data. Leave it for after. There won't be problems. You will be able to store it efficiently, query it efficiently. Just free yourself up, go and model your domain.
Well, you still have to do migrations. You still have to pull every row out of the database and put every row back in. So yeah, you can improve the ergonomics around that, but it's not just, don't worry about the database, go build your data, because no matter, you're going to handle the complexity here, or you're going to handle it there, but a human is going to handle that complexity.
I agree, but what matters is the moment where you pay your attention to the data. So whole process, in my opinion, should start with modeling abstract domain. After your modeling is done, now you start thinking about how to persist that. And then you decide, okay, am I going to store it as it is? Am I going to remodel it a bit? How many subdomains are touching my object? If too many of them are touching, maybe this is a sign that I should isolate into subdomains, which may or may not later become microservices or some logically detached things. But as I said, reversing things. So instead of first thinking about the database and persistence, because you are bearing the scars of many projects where you suffered, you free up yourself, you go and model it, then you see if you can store it as it is, if you need to model it a bit, if you need to reshape it a bit to accommodate persistence storage of your choice, or you need to develop completely separate persistence layer for storing.
I think I agree with that. And I think that there's some project Amy was talking about once that I think has become fairly popular. It's some sort of pure JSON database, not meant at all for production, but just meant for getting a prototype out where everything's stored as JSON files. JSON REST, I think it might have been called, something like that. Do you like that kind of idea of a project?
So here you should look at the JSON as a choice of the format in the function of serializing things over the wire. So you build...
Well, what other format could you possibly use?
Well, you could use whatever you want. Like MongoDB invented
CSV?
BSON.
Oh, but that's just JSON. I mean, it's not different from...
Yes, but the story is following. JSON is appropriate format, which is also widely used, and it's used internally. And we are RavenDB is also transferring that to binary format at the very end. But in some way, when you work with the database, it should be kind of black box. So you throw your object graph at it, database is able to store it, and later on efficiently deliver either these same objects to you, or create projection, which is combining properties from different objects. So if you have, I don't know, typical boring business case of purchase order, you need to display company name, company address, product names, and this is combined from 3, 4, 5 collections or tables.
Yeah, but I mean, Raven can't make that choice of how to decompose it, though, right? I mean, I guess you could do something to automatically say, "Oh, this looks like this. These things are. This looks like an enumerated set, so maybe I can decompose it." But how would it decompose that?
So it's more in the lines of CQRS, where you store your objects as they are. They are stored as complete JSON documents. So when doing modeling, your first choice would be, of course, to present paper physical documents as classes, and then these classes are becoming JSON. So you end up with the JSON representation of the physical objects and concepts from the real world. And then on the read side, you are writing projections in JavaScript or C#, and this code lives within the database. So you could speak of stored procedures in the 21st century, which are not stored procedures anymore. These are pieces of either JavaScript or C#, which are executed on the server side, which is producing projections. So you say to RavenDB, give me purchase order. And you're not getting this purchase order you stored. You got dereferenced purchase order view model, which is composed from 3 or 4, 5 collections. So what you get back from the database is actually a read model, which is completely different from a write model. If you think
this is starting to sound more like CouchDB to me, where you're writing the JavaScript, essentially the filter function or the map filter function as data is going in, so that it's prepared for when the data goes out.
I maybe mentioned it in the beginning that Couchbase was inspiration for this data. Oren.
Yeah, and I was having a little bit of internet trouble, so I may have missed that.
So Oren actually used Couchbase as an inspiration and started thinking how this could be improved to produce something even better. So you may see some design decision traces sourcing from the Couchbase.
Yeah, but one of the problems you're solving, which Couchbase does not attempt to solve, is queries. Because Couchbase, or as I knew it, CouchDB, I guess it's changed names a couple of times, but is you put your data in, you define your reports, essentially, you define your queries, and then the data gets pre-sorted into the query. So everything is cached as literal, could be saved to disk documents. Whereas you are saying, okay, well, you can make a query arbitrarily. We can put an index on that, and then so you can make arbitrary queries with RavenDB. Whereas with Couch, you can't really make an arbitrary query. You can make a report and then have the report run, or I call it a report, but the map filter function, and have it run. But you can't really do a one-off query.
Exactly. And not only that, so if you imagine if you have a purchase order with order lines and you don't have a total value as a part of your model, you then go and create projection, which is using JavaScript to calculate the total from the order lines. And then you have JavaScript or C# performing this action. And not only that, indexes as of 2 years ago can be expanded with C# or JavaScript code. And I was playing around with the following thing. I went to Kaggle. I downloaded a huge collection of tweets about airline companies. I trained...
What did you go to?
Kaggle.
Kaggle, it's a place where you share machine learning and other tools.
Big data sets.
Yeah.
So what I did, I trained machine learning model that is recognizing toxic text, profanities, and other things. And then I wrote code which is grading, scoring arbitrary text against toxicity. And I plugged in that into RavenDB. So RavenDB was in real time using indexing to score incoming tweets, which I'm saying to the database. So again, I have stored procedures in 21st centuries where I can expand functionality of the database with my custom code. Or for example, I can, if I'm using attachments, I can create document management system easily where I'm using indexing and I'm streaming content of the attachments and using Lucene full text search index to produce full text index of the attached files. And these attached files can even be, for example, zip archive, which I will unzip on the fly. Database will pick up the stream content from stream and produce index. So idea here is to make life easier, to make things work out of the box whenever possible. Or, for example, if I'm building microservices, you would have to provide message queue with inbox pattern implemented and outbox pattern. Some of the companies using RavenDB are using RavenDB ETL, where two Raven databases can communicate with each other, taking JSON documents, morphing them, and pushing or loading into second database. So in some cases, instead of microservices communicating with messages with each other, you simply write a small piece of JavaScript, which is transforming, pushing to another database. So you eliminated a need for queue, outbox, inbox, like retrying communication if it fails, etc.
Interesting. I kind of wanted to ask about things as far as like data science and data systems, machine learning goes. You know, how much data can Raven handle? It seems like a lot of these, you know, like you said, you know, you set up a cluster of however many machines and you can more or less scale it as big as you want. Where do you start losing efficiency? Is it when you spend more than one machine? Because there's always latency over the internet or the network, right? So yeah, what does that look like as far as like scaling and then processing, you know, where I can either do some of my algorithms sometimes within a database and sometimes the algorithms have to be run through like a Python with PyTorch or something like that.
So coming back to the question about the difference with MongoDB. So for example, MongoDB has a dedicated primary node, which is accepting writes.
Okay.
Again, this side decision with RavenDB was to provide multi-master setup where you have, for example, cluster of 3 equal nodes with 3 exact copies of your database on each one of these nodes. So let's imagine you have cluster of 9 nodes. You can sustain the loss of 8 of them, and the remaining one will be serving your application perfectly.
How do you manage consistency across the nodes?
You can run local transactions, and then Gossip protocol is used to distribute that. You can run cluster-wide transactions.
The Gossip protocol?
Yes. So there are 2 layers of topology. When you look at the machines, a Raft distributed consensus algorithm is used for the machines. So you need to have majority of the nodes up and running to have clustered in technical terms. So to build a quorum or majority, you need to have majority of the nodes, obviously. Mm-hmm. So you need to have, for example, in cluster of 3 nodes, you need to have 2 nodes available to perform cluster operation like creation of a new database. However, once you create your database, you descend to second layer of topology, which is database group topology. And on that level, Gossip protocol is used to disseminate data from one node to the rest of the nodes in the cluster. Now, what you can do, you can create local transactions where you store to just one node and this node disseminates to the rest of the nodes. Or you can go with cluster-wide transaction where your transaction will be over when majority or all of them accept your changes. Or you can go middle ground saying, okay, I'm writing to single node and I'm waiting for the guaranteed number of replications. This is in the midway between local transactions and the full cluster transactions. So it's more like you having a choice as a developer to determine which business case should be handled by which technical features. So if you're selling tickets for the Super Bowl, you want to have cluster-wide transactions because you have consensus, and you won't be able to run into the case of selling same seat to 2 or 3 people.
Yeah, they wouldn't like that.
Yeah, but if you have something simpler, then you can say, okay, I'm going to write to a single node and wait for guaranteed replication to at least one more node. Or you will say, okay, I'm writing to this node and that's it.
Gotcha.
Maybe I went too far on a tangent. Maybe I did not answer your question.
No, I don't think so. I think you're good. One other question that I have, though, is, so if I have all the data on one node, then what's the limit on the size of my database?
Yes, this is something I did not answer. At the moment, it's around 15 terabytes. But sharding, the last big feature which is missing, is under development. So in something like a month or 2, we will have first version supporting sharding.
And then the sky's the limit because I can run this across however many nodes. Yeah,
but I think when I speak to people, they ask me about the sharding almost as if they have like checklist checking. Is this data?
That's true. I've never run a 15 terabyte node or a 15 terabyte database.
And that was something I was going to mention earlier, Chuck, when you were talking about the weekly report. It wouldn't matter if the indexes die after 3 days if you're running a weekly report because you're only running it once a week.
Yeah.
A lot of these scenarios that we, just like you're saying here, people have these checkboxes in their head, but they don't actually think, do I need the checkbox? Is
right.
the checkbox important for me? It's just, this is what was on the whiteboard when I was in college, and this is what my uni professor said, therefore.
Right. I don't need the index to necessarily build the report. It's built when it's built. But my users will drift away and not buy my product or not use my system if it's too slow. That's where I actually care about speed. So yeah, point made.
It's also, I remember on a couple of occasions, companies where you have BI department running reports and killing database CPU peaks to 100%.
Oh, yeah.
And then you say, okay, you will do your reports on Monday morning up until 10 a.m. That's it. You need to finish. And then you establish read replica just for the BI department to run their report.
Yeah, that's what we always did on the once it became too intensive. We just spin up a read replica and say, go nuts, right? Because you can peg the read replica and nobody else will feel it.
But you see, over time, you start to build these fears. Either you like it or not, you start fearing, okay, what will happen with my project when someone runs reports? And at least I want to avoid that.
Yeah, makes sense. All right, we're kind of getting toward the end of our time. Is there anything else that people need to know about NoSQL databases or RavenDB before we do picks?
I notice people still are, although NoSQL is almost 20 years old as a movement, I would call it a movement, I'm noticing people are still like driving an autopilot and selecting relational databases, which is not a wrong choice. It's just that this choice should be conscious and informed and based on concrete project and concrete needs.
Right.
It's also okay to use text files if it's one-off project.
So the biggest problem with SQL is that it's not standardized.
Precisely.
Because for a standard query language, there's no standard. There's all these little tiny gotchas of, in MS SQL you escape with a bracket, but in Postgres, identifiers are single quotes, but values are double quotes. But in MySQL, it can be backticks for identifiers and for values sometimes. And SQLite tries to play the middle ground. I think it leans more towards the Postgres way of things, but it's just more lenient in general. But then if you go to the NoSQL arena, well, then it's even worse because now everything is bespoke. And rather than being able to build things in just the query language, for example, for the stored procedure or the view, or however you want to use the right terminology to capture the essence of what you were talking about as a projection earlier. Now it's okay. Well, if we commit to this platform, we have to also commit to the programming language, which I mean really isn't that hard of a thing to commit to because you're going to anyway. But you're tying more things in together with NoSQL, and there's not even an attempt of a standard. There's not a dictionary of, hey, here's what projection means, right? Projection is a bespoke term for RavenDB, and what Couch calls its kind of projection, which might be a little bit derogatory towards RavenDB because it sounds like a RavenDB projection is a bit more than what the CouchDB, what I would call report is. I don't remember what the name is for their map filter function, and so on and so forth. So it's easier that you talked earlier about the cognitive load, and this is one of the reasons why I'm suggesting something like Marten. Is it's easier for people to gravitate towards something that at least has some semblance of both stability and similarity, as opposed to this wild west of, well, everything's different and it changes all the time.
Standards do matter. I completely agree. And probably that's major factor in the success of Postgre.
Yeah, Postgres has a lot of really good tooling built around it in every language. Now, granted, it's not the same tooling in every language, but you can find great Postgres tools for Rust and great Postgres tools for Go and decent Postgres tools for Node and so on and so forth. I imagine for C#, like you mentioned. So I think that's part of the draw, and that's kind of why I said, I'd really love to see something like Raven, but built on top of Postgres, so I have that sense of security. And also, like we saw with RethinkDB. RethinkDB was something where they had a lot of cool concepts. They had a lot of ideas that really started to make sense in the second iteration of the product. Because the first iteration was all about optimizing rotational storage, and I don't think anybody even heard about them yet. Then they got investment, they started to get big, and then they were all about kind of being in the Mongo space, maybe kind of in this Raven space. So there was a venture-backed company, they were big, they were pumping things out, and then all of a sudden they disappeared overnight. And that's another, concern for someone that's starting, whether it's a new project or it's transitioning an old project. How do you get, not just with NoSQL in general, which I think is well categorized as having been a fad. Obviously, it's still around, but in terms of just new things every week, and Mongo kind of stuck around. Redis, I don't know that it really fits with NoSQL. It's just a caching layer or a key value store, which we've had those for decades upon decades upon decades. That's exactly what other databases have been built on traditionally, has been binary key value stores. But so with all of this negativity, what is something that you feel that Raven brings to the table to assuage some of those fears of, hey, Raven's kind of going to be stable and Raven's going to be around for me to continue to use?
So I completely agree with you. And this is probably the biggest challenge and probably one of the hardest market to enter, because you are producing something that's used as a part of infrastructure, and changing database is painful. You don't want to do it, or if you're going to do it, you want to do it once every 20 years. What I see is that developers love RavenDB. And in most of the organizations, I was facing following scenarios. Developers go home, work in the evening on the hobby project using RavenDB. They go back to the work saying, I tried this database on my hobby project. It seems to be working nice. I did some load testing. It's also nice. I would like to use it for our next project. And then manager says, okay, I never heard about this database. Googles around a bit, says, okay, this is the same thing as Cosmos DB, and the Cosmos DB is a big name. Why shouldn't we be going with Cosmos DB? But devil lies in the details. It's when you start developing, when you start living with your choices, it's about what matters. So I think as a general rule of thumb, managers should have more confidence in their teams, in their developers, whatever their choice of technology might be.
So also, I need to boost something on the...
I need to push us to pick soon, so go fast.
Okay. Well, on the practical side of things, it seems that you have a good business model. And that is one reason that I would believe that you would stick around, is you seem to be charging reasonable prices for, your basic tier is about $1,000 per year per CPU core. You've got a community tier that's free, and that gives me some degree of confidence. If I'm paying $1,000 for something, I have some degree of confidence.
And it's also open source. It's interesting business case. Completely open source AGPL 3 license. So you can go and fork it if you want. And I think community by now is large enough. So even in the case of like a rock from the sky hitting headquarters and all developers are gone, I think community is at this point large and strong enough that they will continue to push it. I'm a strong believer and strong proponent of open source. I think it's great as a concept. And when you see that someone built a company around it over something that's completely free, that's amazing.
So when you say the AFGPL, though, doesn't that mean that any service that I connect over HTTP is infected with that license as well?
If it's not part of the application, it's not. I would have to go into strict details to see what is, but if it's not embedded as a part of the application, I think it can be used. But there's also what's interesting. There's community license, which is suitable for commercial usage. And
right.
Lots of startups are using it. And at some point, they reach out to you. Okay, I've been using this for 3 years now. We are profitable. We want to contribute back. So those are interesting stories.
All right. I'm going to push us to picks. We should do another episode on licensing because I find that fascinating. I'll find us an attorney to talk to. But let's go to picks. Hi, this is Charles Max Wood from Top End Devs. And lately I've been coaching some people on starting some podcasts and in some cases, just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching. Steve, do you want to take us to what you consider the high point, as you always say, of our episode?
Yes, but I will get there very briefly, but I actually did have a legit pick. Well, my picks are always legit, but a different one. So I came across this page on Twitter, I think today, and it's really cool. It's low Earth orbit visualization map, and it shows all the different low Earth orbit satellites that are floating around in the ether above us, and gives you ways that you can sort of see when they might be traveling over your particular geographic location, and gives you the ability to see them. So looks like a pretty cool little thing. I've done that before with the International Space Station, where you figured out when it's coming over, and then you go outside and you can see it go overhead. So it's platform.leolabs.space/visualization. So we'll put that in the notes. And then it's also worth mentioning, I guess one of my picks is Utah. Last week,
I've been there before.
My daughter and I spent the week driving around doing a big loop through Utah and a bunch of the national parks. I got to see like arches and Canyonlands in eastern Utah, went down to Lake Powell, and then did Bryce Canyon. It's gorgeous. I love that Canyonlands type. Oh, Monument Valley too, right on the border. I love Monument Valley. It's, it was used as a John Ford, movie director, used it for a lot of his Westerns, and you just see pictures all over the place. And there's actually a scene from Forrest Gump when he's out running around where they take a picture on Highway 163 going through Monument Valley. And if you look on Google Maps, it says highway used in Forrest Gump movie. So got some really awesome pictures. Funny story, I also got to meet AJ and his lovely wife, Agnes, in the Provo area. And we went out to dinner one night. Funniest thing, and developers will understand this. We're sitting there talking. Agnes looks at me and goes, "So, Steve, how many computers displays do you have?" And I guessed right away that AJ had a whole bunch and she didn't understand them. I said, "Well, I actually have 5. And she's like, "Oh, no." She was hoping that I wouldn't agree with AJ. I've got my 3 big monitors and 2 laptops and all this. But it was really funny. My daughter just loved Daddy. His daughter, she was real cutie. But then all that, getting on to the high point, the jokes. So I had them all brought up and then I lost them. Oh, yeah. So usually I tell, audio jokes, but I actually have a bunch of jokes that are in sign language, but I can guarantee that nobody's ever heard them, right? So what is the difference between a camera and a foot? And I found this because I was taking a lot of pictures last week. A camera has photos and a foot has 5 toes. And then finally, this was sort of a leftover from St. Patrick's Day, which was a couple weeks ago before I left on vacation. Why are leprechauns so hard to get along with? Because they're so short-tempered. Thank you.
Nice.
That is my picks for the week.
All right, AJ, save us.
Well, first of all, I was muted, but I didn't get that last one. Can you help me a little bit?
What about the leprechaun?
Yeah.
Because they're short-tempered. Leprechauns are short people.
Sorry.
It's like, where do you find a leprechaun baseball team? In the Little League.
Sorry. I'm
Save us!
Okay. All right. Wow. No, you hurt my ears there a little bit, Chuck. So I'm going to pick one, Ethan Garofalo. He's got a few talks on microservices that I have in a playlist. I should go and search out what his latest ones are, because the latest one I have is from 2019, and he's probably done more since then. But I like to keep up to date on his playlists, or his talks, I guess. They're good talks. Anyway, so Ethan Garofalo, he's literally written the book on microservices. We had him on the show once. I should probably pick whatever show that was, but I don't remember what it was. And then also there's this YouTube channel that makes fun of developers, but it has one pretty much, it's all but a documentary, and it's called Microservices. And I swear I've been in the room. I've seen that happen. It's hilarious, but it's someone explaining on the whiteboard why we can't get the user's birthday into their profile information. And it's
Galactus.
Yeah. and then he actually has somewhat of a follow-up called I Delivered Value, but at what cost? It's not as funny, but it's it's when they finally are implementing the dates into a megastar.
Yeah.
That wasn't a joke. That was just me laughing, thinking about it. Anyway.
They were all laughing with you.
Not at you.
Oh, okay, good. And then the last thing that I had to pick, I had something else to pick. What was it? Oh, the Brandon Sanderson. Yeah. I was going to pick Brandon Sanderson as they refer to him, quote, in the world of the fantasy fandom, our Lord and Savior, Brando Sando. See, he is the best fantasy author of all time. He finished The Wheel of Time. He created Elantris and the Mistborn series, and now his magnum opus is The Way of Kings / Stormlight Archives. And he, during the pandemic, was, really down and wasn't able to go to any conferences. And so then, boop, out of nowhere, he announces that he actually wrote 4 whole books over the last 2 years, in addition to the books that he was contracted to write. And so over the next 2 years, we're going to get another 6 books from him. And he made a Kickstarter where you can get kind of I don't know if it's a special edition of these books, but they're I think most of them are in the Cosmere. I think 3 of the 4 are in the Cosmere. I don't remember what he said exactly. And then there's going to be swag boxes and all this stuff. And so you can get the audiobooks sorry, actually, I'm mentioning this too late, because by the time this goes out, it'll be over.
Mm-hmm.
But anyway, check it out. Maybe there will still be one of those Indiegogo things where you can sign up after the fact and still get it. But my wife and I got the audiobooks and maybe some of the other extras as well.
Yeah, I want it. Yeah. Sorry, did I cut you off?
Nope, that's it. That's all I got. Just
all right.
Fanboying out.
I'm going to throw out some picks. Then the first pick I have is board game. It's called Scythe on Board Game Geek. It has a weight of 3.43, so it's on the heavier end of games, but it's a fun one. It's a resource collect and manage build game. So it's kind of in the vein of Settlers of Catan, kind of, for lack of a better way to put it. But it's fun. You get to fight other armies as well, but the combat's not really the point of the thing. So anyway, really enjoy that game. We have one of the expansions too, and I'm trying to remember which one it is, but I'll have to pick it a different time. Another pick I have, so I am finalizing things for the summits this year. It looks like the JavaScript one will probably be in July. I'm reaching out to a few folks like Brendan Ike, some of the more popular guests that we've had, I guess, to see if they want to come on and speak. So keep an eye out for that. Got DHH coming for Rails in August. Probably do Angular, React, Vue, etc. during the fall and winter. So anyway, if you're interested in any of those topics and showing up for some online conferences, definitely do that. Now, I'm doing it a little different than I have in the past, because I know some people have come to the conferences that I've done in the past. I'm trying to make it as easy for attendees to interact as possible. So we'll have a Slack room like I've always done. It'll actually be the chat in the software I'm using, but then we're going to have tables for people just to sit and video chat with each other, which is all built in. You'll be able to go talk to the vendors, and I'm working on doing giveaways as part of the deal and seeing if I get the sponsors to give away stuff that we can give away online, right? You don't have to be present to win sort of thing. I don't have to figure out how to ship you a thing. But the other thing is that all the attendees will get an NFT for the conference. And I'm working on getting NFTs for just other kind of like badges almost that you can earn as part of the conference, right? So if you talk to a certain number of people or visit a certain number of sponsors or visit specific sponsors or things like that, you'll get entered into their drawings and you'll get their NFTs. So anyway, it'll be super fun. I'm looking at doing themed days. And so, we might do a day-to-day and have like a Postgres expert and a Raven expert and, whoever show up. So anyway.
This is where I want that movie quote from Treasure of the Sierra Madre about badges. We don't need no stinking badges.
Right.
I think I have to upload that as a sound effect.
You might have to. But anyway, you can find all the details at jsremoteconf.com. You can find the details on all the conferences at topenddevs.com/conferences. And I think that pretty well wraps that up. The only other pick I have is, so I was at Nashville this last weekend. It's funny because Steve comes here, so I left town. But I wasn't trying to be fun. Anyway.
Oh.
One of my friends got me turned on to Yellowstone, the TV series, and it's really, really good. So I'm going to pick Yellowstone.
Have you started to watch any of the prequel that just came out that's got Sam? I forget.
I want to. I haven't yet. I was kind of. I think it's 1883.
1883, right?
But yeah, I haven't picked it up. I've heard that from a lot of people that they like it better than than Yellowstone. So anyway, apparently they're looking at making another one, which is like 1923 or 1933. I don't know. Anyway, so yeah, apparently 1883 is just a one season. It's a one-off series.
Oh,
but anyway, and this is all hearsay. I don't know any of this. So it's what they were telling me. Anyway, but yeah, I'm going to pick Yellowstone. I'll probably come back around and pick 1883 if it's as good as Yellowstone is. But yeah, anyway, that's my pick. Dejan, what are your picks?
Okay, I'm rather boring. So my free time, what I do, I'm coding. So this week I'm playing around with a programming language called Idris. And what's so spectacular, in my humble opinion, about it, it is so strongly typed that compiler is not a device for catching your errors anymore, but compiler can use type declarations that you prepare and generate part of the code for you. So you have this interactive mode where you say, okay, this is a signature of the method, and this is function programming language, and it will generate a good part of the code for you. And then you can even go and write formal proofs for your code. And I don't know if you're aware, but for example, when you use Firefox, TLS implementation in the Firefox was generated this way. They took programming language called FSAR. They wrote formally proven implementation of the TLS, and then they generated C code that was compiled and built into the Firefox. And the best part is during the implementation, while following TLS protocol, they managed to find a couple of the errors in the protocol itself, in the specification of the protocol. So I think formally proven pieces of software are future to come. So usually they say it takes around 20 years for innovations to land in the industry. So I'm playing, hopefully, at the moment with something that will arrive around 2050 into our lives, making us all safer and happier.
Awesome. Now, one thing I forgot to ask earlier, if people want to find you online or connect with you in some way, where do they go?
I'm trying to use Twitter in a very nice way by sharing the links so they can find me on Twitter. So that's my favorite social network.
Awesome. All right. Well, we'll go ahead and wrap it up here. Thank you for coming. This was awesome. And until next time, folks, max out.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.